weighted graphs and networks. A weighted graph is a graph that actually has numbers on the edges. These numbers are called weights. Now they can be anything. It could stand for time, it could stand for cost, it could stand for distance. It doesn't matter what it stands for, we just adapt what we're writing for it. So example 1 says a network opposite is used to model the tracks in a forest connecting the suspension bridge, which is B, a waterfall W, a very old tree T, and a fern gully F. Walkers can enter or leave the forest through gate 1 G1 or gate 2 G2. The numbers on the edges represent the times in minutes taken to walk directly between these places. Part A, how long does it take to walk from the bridge directly to the fern? Well, if we do the bridge, there's the bridge there to the fern is there, so we can walk directly there. It's going to take 12 minutes. Part B, how long does it take to walk from the old tree to the fern via the waterfall and the bridge? So I'll do this in green. So from the old tree to the fern. So we've got to go to the fern. So we're going to start here. So the tree, this is part B. We're going to go via the waterfall, so there to W, and then to the bridge, so to there to B, and then to that one. So we've got 10 plus 9 plus 12. So we've got 31 minutes for part B. Shortest path problem. Now the shortest path, or the shortest distance, shortest time, least cost to move around the network is what's called the shortest path. Now, example 2. Find the shortest path between town C and town F. So there's town C and there's town F in the previous network opposite. Right, so let's try and work it out. So I'm going to go from C to B to A and then to F. So I've got C to B to A to F. So when I do this, I've got 5 plus 7 plus 6. I'm looking at 18. I'm going to just see if I can find something that's shorter than that. So if I do that one there, I'm going to go from C to B, then I'm going to go down here to E and then to F. So C to B to E and then to F. So this is 5 plus 4 plus 7, which I've got as 16. And I can't see any other ones. So if I do 6 along here, C to D, 6 and 9, that's 15, and 7 is going to be too high. So you've got to try and work these out like this. But there is a thing called Digastra's algorithm, which will help us find the shortest path from A to F. Now I'm going to show you slightly different than what the book says. Okay, so I'm going to start off from A because it says to A and we've got to get to F. So there's my A. So I've already put that on this column. I'll do a double line here. Double line here because that's where I'm going to put it. A can only go to B and to C. Okay, so B and C. A can connect to B in 2. Whether it's 2 minutes, 2 hours, I don't know. And it connects to C in 6. And because it's coming from A, I'm going to put the letter A here. Now I'm going to circle the smallest one. 2 and 6, 2 is my smallest. Okay. So now that I've done that, and that came from B, I'm going to put B here. Okay, B. B can only connect, we don't want to go back to A, can connect to C, to D and to E. Well, it connects to C in 2, but I've got to add this 2 that's already there. 2 plus 2 is 4. Is that smaller than this in the number here, 6? Yes, it is. So 4, and this is coming from the letter B. It also connects to D, so I'll put D here, and it also connects to E. Okay, connects to D in 3. But remember, I first have to get to B, so it's the 2 that I've got plus the 3, 5. 5 from the letter B, because that's where I'm coming from, and connects to E in 2. 2 plus the 2 that I've already got is 4. and that's from B. So you can see I'm going to here, and either here or here. Which one's my smallest one out of those three? That one there. So C is going to be my next number. Okay, C. I'm just going to make this a bit smaller so we can see it. Okay, C. C can connect to B. B's already there, forget it. It can connect to D. Okay, B's got a circle around it. That's what I need to get it. C to D is 1. Okay, 1 plus the 4 here is 5. I've already got a 5 that's there, so 5B. No point going. I might as well leave that one there. And that's all C connects to that haven't got a circle in the column. So I'm going to just drop this one here for B. Smallest number is, of course, the 4, and that's coming from letter E. Okay, E. E can connect to E. E can connect to D or F. Let's do D. So it connects to D in 2 ways, or circle scribbled all over that. 2 plus 4, as we've circled the 4, 2 plus 4 is 6. I've got a 5, so 5 is still the smallest. And it connects to F in 3. 3 plus 4 is 7, and that's coming from letter E. But changing this letter here, that still remains as a B because we have the B here. Smallest one is that one there, so D. D connects to E, it's already got a circle in it there. D connects to F in 5. 5 plus this 5 over here is 10, while this 7 coming from E is the smallest one. 7 from E, and I have finished. So, shortest path, I'm going to go backwards, start here. F came from that 7, which was letter E. Okay, E, we've got letter B. That is my circle at B. Okay, column B is here, 2, and that came from the A. What's my shortest path of distance? The 7. 7 is my shortest distance. And that goes from A to B to E and to F. So A to B to E to F. That's a distance of 7. And that's how we use Digastra's algorithm. I put the letters on the number so I know where it's coming from. It's easier for me. Okay, example 4. Use Digastra's algorithm to determine the shortest path from S to F in the following network. Okay, so S. Let me just set this up. S. Don't need to put the 2 strokes, I do, just to help you guys out and utilise all this. S connects to A, connects to B, and connects C. Doesn't matter how you write them up the top there. Okay, S to A is in 7, S to B is 5, S to C is 8. And I'm going to put letter S because that's what they come from. And the smallest one is number 5. Okay, so I'm going to put the B there. Keep it. All right, now B connects to D and E. To D in 4. 4 plus 5. No, there's no D there. 4 plus 5 is 9. So 9 from letter B. And to E, 7. 7 plus the 5 is 12. And that's from the E. Oops, and because column A doesn't have one, I'm just going to drop that one, and column C doesn't have one, I'm just going to drop that one. And that's an S, remember? Smallest number out of those, number 7. So, column A here. A only connects to D in 3. Okay, 3 plus 7 is 10, because I've got to add this 7 here. 10, but I've already got a 9 coming from B. 9 is smaller than 10, so I'm going to put the 9 there. That's all A connects to, so I'll just drop this one again, and this one again. Smallest number is the 8. So now I'm going to be looking at C. C only connects to E in 2. I've already got an E there, but that's 12. 8 that we've got here, and the 2 is 10. 10 is smaller than the 12, so I'm going to put the 10, and that's coming from C in my column E, because it's connecting to E. I'll drop this 9B. Okay, smallest one is that one there. That's D. Okay, D. D is here. Don't worry about going to B. It's already got one. Don't worry about, that's it, A, but I'm going to do E. D to E is 1. 1 plus 9 is 10. I've already got a 10 coming from C. I can just keep the 10 coming from C. I don't need to change it. And it's going from E to F. D to F is 6. 6 and 9 is 15. There's no number in F, so I'm going to put that, and this one's coming from number D. Letter D. Smallest one is this one here from E. Okay, let me write E down. Just scroll a bit. Okay, this one's going to be E. Okay, E, don't worry about going to D, it's already got a circle. E to F is in 8, 8, and this 10 that I've got around the circle around is 18, 15 is still smaller than 18, so 15 from D. So I have reached my F. So going backwards, F is going to go to the letter D. D is going to go to letter B. Letter B is S. So S to B to D to F is my shortest path, and it's going to take me 15. I don't know if it's 15 hours, 15 weeks, but that's my shortest path there.